Hey guys, so now what we're going to do is we're going to move into more of the components of a quadratic. Yesterday we talked about just two parts, the roots and the vertex, and we also talked about graphing it. But now we're going to get into a couple of more things. And a lot of the times you can tell both all components either from the table or the graph or even both. So I'm going to go into both of them and I'm going to show you how you need to represent all of your information as you're going through. And then I'm going to just give you a little spiel about how the Delta Math they're going to want you to record your answers. All right. So first thing is, let's just go over. We looked at three different types of quadratic equations. We have standard form, we have vertex form, and we have intercept form. Now, each one of our quadratics can be written in one of those ways, and they can all virtually come out to the same equation. Not virtually, they would. It just tells you a little bit about each of the components of a function, a quadratic function. So in standard form, in vertex form, you can find your vertex, and then in root form, you could find your roots. So first you need to memorize that the graph of a quadratic is called a parabola. That's a big thing. We're going to use that word a lot. Next thing I want to also talk about is your roots. Your roots are where the parabola crosses the x-axis. So this is where I'm going to go into a little detail. This root here, if you notice, it's x equals 2. And this root is 1, 2, 3, 4, 5, 6. X equals 6. And then this root is -1, -2, -3. X equals -3. So that's one way you could write your roots. Your roots can be x equals or two separate answers, sometimes one and sometimes none, or sometimes your roots are going to be represented as points. On Delta Math, though, today, you're going to be representing them as two separate answers. And obviously one answer if it's only one root. And then that root over here can be -3, 0. So know that they could be written in both ways, x equals as two answers or as 2 points. Now what we're going to do is we're going to go on the next page, and I apologize about that. Your vertex or turning point, we talked about it yesterday, it talks about your max or your min. It's where your parabola turns. It could also be called your turning point. It also has a little bit more of an impact as well. A lot of our analyzing deals with the vertex. So that's something that we're going to get into later as well. And that's here, the axis is symmetry. You could hear it in the word. Axis is a line, and symmetry is a line that cuts something in half. The axis of symmetry goes through the vertex, and those two are completely related and very important. All right, next thing we want to also memorize, sometimes you don't need to look at a graph to see if something has a maximum or minimum point. You can actually look at the equation. So if there's a negative in front of your x squared, remember that flips our equation. That would make us have a maximum point because the graph is opening downward. And the same goes for the opposite way. If your x squared has a positive number in front, it just means it has a minimum value because it's opening upward, like our normal parabola. So this is something that you should also kind of be aware of. Next thing we're going to look at is our end behavior. Your end behavior just talks about how a graph is, just looking at where it's pointing. If you look at this first one, the end behavior, you'll notice the arrows are pointing up, so it's opening upward. You'll notice down here that the arrows are pointing down, so it's opening downward. Again, they're related to the fact that if your x squared, the coefficient in front of x squared is positive, it opens up. If your coefficient in front of x squared is negative, it opens down. So you don't necessarily need to graph it to see that, but you can. That's the beauty of graphing. Number 6, we're going to talk about the axis of symmetry. Now, this is another thing that's really important. The axis of symmetry is a line that cuts through the vertex or the turning point. And we will talk about how to get it algebraically, which is using this formula. And maybe some of you notice a B and an A, and those numbers are part of the quadratic formula as well. But your axis of symmetry is connected to the vertex. So like here, the vertex for this pink parabola here is -3, 4. If you just mapped it out from the origin, you go left 3, down 4, it'd be -3, -3, -4. So The axis of symmetry is just the x value of your of the vertex. So if you have this guy here, the vertex is 3 up 4, so that would be positive 3, 4. So therefore your axis of symmetry would be x equals, and you just take the number for the x value of your vertex. Now remember, equation axis is just another word for saying line of symmetry, and our equations of lines are usually y equals mx plus b. But obviously, since this is a vertical line, it's an x equals line. And we talked about those in the beginning of the year. So just remember, your axis of symmetry is an equation, your vertex is a point, and your roots are 2 answers. So those are 3 things you're going to have to remember for the Delta Math today. And then one other thing you're going to need to memorize is your graph behavior. If you go from left to right on your graph, if you watch this color, it's going down and then it hits the turning point or the vertex and then it starts to go up. So that just means it decreases, then increases, where if it's opening downward, it increases, hits a max point, and then turns and decreases. So that's what we call graph behavior. And then number 8 are your points of symmetry. Those are the points in our table where we find our like rainbow effect, like we call it. Those are the points that are on the exact same spot, but on opposite sides of the axis of symmetry, I guess, for lack of a better term, or exactly at the same position on the parabola, but on opposite sides. Those are your points of symmetry. All right, so what I want you to do right now is we're going to look at this one together. I would love for you guys, so what I'm going to ask you to do is there's these open boxes. And for each open box, you're going to fill it. Whoopsies. You're going to fill in one of these words. And I want to see, okay, axis of symmetry you're drawing, but each one of these has a word. And then this, you're just going to, I'm just telling you the graph behavior. So the ones that I have check marks next to, you're going to be filling into the blank boxes that are on the screen right there. And then when you're done with that, I would love for you to then go into your calculator, graph that equation, and copy down the appropriate table that we would need in order to graph this. So I want to test your ability right now. We talked about a little bit of this stuff yesterday, and now I want to see how much you can match up from the vocab that we just did. So I want you to pause the video and see if you can place the vocabulary in the right spot. And then when you're done, unpause the video to see if you're correct. Okay, so this is what you should have. Your table should start at -6 and go to 3. And you should have been using that calc button in your calculator to find that vertex, because it was, if you can notice here, it's in the middle of the 2 boxes. So we know the vertex has to be a 0.5. So you definitely want to do your second calc, second trace, and then do your minimum here. So you should have opens up, the roots, points of symmetry. Then this is your y-intercept. I didn't go into detail on that because that's pretty much a given. We already talked about y-intercepts before. And then you have your minimum and vertex. Now, what I want to go into detail here is just writing out the answers also, because you need to know how to write them out in numerical form. So your roots, next to roots, I want you to write, it's either x equals -6, comma, x equals 3. Now, how do I know that? Because I know my roots are where my y is 0. Or you can write them as the points that you see them, which is -6, 0, and 3, 0. Okay, so that's your first one. Now your vertex we already said was -1.5, comma, -20.25. So you just take that out of the table. That's the turning point or the minimum. Your axis of symmetry, I didn't draw in there, but I'm also going to write it as an equation. Your axis of symmetry is this line that goes through the vertex. It's really important that you know how to name it as well. The axis of symmetry is x equals, remember it's always x equals, and it's the x coordinate from your vertex, which is -1.5. Okay? The next one, we know the end behaviors opens up. Your y-intercept was over here, but you can also find it in your table because that's where x is 0. So that's your y-intercept, 0, negative 18. Points of symmetry, I'm not going to worry about that because you guys can see them in the table. But these are the most important details that you need, those numbers that I wrote down, okay? Pause the video and make sure you have everything on here written on your paper so you have it as a reference when you do your delta math, okay? So what I'm going to ask you to do is now complete the next one on your own, and then you're going to check the answer with the answer key provided on the Google Classroom. If you got any of it wrong, please watch the second video where I guide you through the examples. And then last, you're just going to complete the delta math assignment on all the different parts of a parabola. And you're going to need your vocab list because it's super vocabulary based. If you don't have this memorized or you don't look, it's going to be impossible. Message me if you have any questions.